All right. Commissioner, if I could, I'm going to start with you. Obviously, I think most people associate Texas with the oil and gas industry, but they may not quite understand the magnitude of the importance of the industry, the state of Texas. So I think in order for us to really appreciate what is happening in terms of the synergies between oil and gas and nuclear, a little bit of level setting about the importance of the industry, the oil and gas industry to the state of Texas, historically and, certainly today.
I think we're down to 2 mics here, so. Okay, 3 mics. I don't know where mine went. Probably better you didn't give me one anyway. That's a good question. Thanks. Okay. Good question. Thanks for asking. Today, oil and gas for the state of Texas is probably the biggest contributor that we have as far as our economic success going in Texas today. I think most people know that. I'll just give you some examples of what oil and gas did for just the state of Texas and its tax base this previous year, which was just north of $25 billion. It broke a record from the previous year, which broke a record from the previous year. Today, we're producing roughly around 6 million barrels of crude oil a day and about 30 billion cubic feet of natural gas on a daily basis. That's a lot. It has actually ranked Texas now number 4 in the world as far as production is concerned. So when we talk about our success with oil and gas, it's important that we consider all sources of electricity that can be generated. And nuclear certainly is part of that equation. Around 2007, we've had air emission rules that have come in and have had an impact on the oil and gas industry, rightfully so. But it also forced our industry to look more on and rely more on electricity to run its compressors and its pumps and all the other things so that we could cut those emission sources down from actually having natural gas-fired engines. So when we look at what nuclear could provide for the oil and gas industry, I feel like it could provide a great certainty for those people that rely on our production out of Texas, not just domestically or here within the state, but for those that we've developed relationships abroad, especially, in the European countries and in Asia countries that we deal with every day.
Simon, wanted to thank you for being here. Wanted to ask you, just help the audience kind of understand your technology and then provide your perspective on how it's well suited to solve the Permian's electricity needs.
Thanks very much. It's a pleasure to be here. So we're developing a generation. A pleasure to be here, Reed. Thank you. We're developing a Generation 4 small modular reactor. It uses molten salt reactor technology. The reason we're doing it is with that technology choice and our design format, we can create a nuclear power plant that generates high-quality heat. That's very good for efficient power generation. And we can also build a nuclear plant that supplies, on a primary basis, a substitute to fossil fuel combustion for the industrial sector, and Dow and others are interested in this. In terms of its relevance to increasing production in the Permian Basin, I think that is the electrification of the Permian Basin and the challenge of increasing energy supply to increase production is actually quite unique, because the Permian Basin in its 2 parts, on the east you have Delaware and the Midland Basin as well. The energy demand is very diffuse. It's not as if you have massive single point points of electricity demand. So you need to build a grid because you need some way of aggregating that demand. And at the right point of aggregation, you can put a supply asset down for electrification. If you aggregate the whole thing up, you could probably put a couple of massive nukes down, but the challenge about that as a format is you probably need to overcommit capital to build out a massive electricity supply infrastructure. That's expensive. But if you have a grid, a classic grid, a matrix grid, and on that matrix grid you put smaller nuclear power plants such as ours, 200, 300 megawatt electrical, you could on that grid have the opportunity to efficiently electrify. Namely, you're keeping the capital commitment to distribution infrastructure to a relative minimum, because you're avoiding the massive cabling that you need to bring in from a big nuke. That would potentially be, from an infrastructure perspective, the optimum advantage. And with that grid-type approach, you would have a great deal of reliability. You have an awful lot of redundancy if you put a lot of small modular reactors on that grid. But it's quite an interesting project and an interesting opportunity for SMRs, because the demand side of this problem from an energy perspective is quite unique. It's diffuse over maybe 40,000 square miles. And the challenge is, both to develop it, is to have enough electrification and enough distributed generation. And getting that balance right is actually, I think, a very interesting energy problem today. Yeah.
Doug, just wanted to maybe piggyback on that and get your, we talked a little bit earlier about your appointment to Governor Perry's Energy Task Force and some of the needs there. Wanted to get your take on how advanced reactors can simultaneously address the needs of oil and gas while also helping to solve the state's bigger electricity issues.
Yep. So with a small
Sorry,
modular reactor... Sorry.
That one's for Doug, sorry.
The other molten salt.
Oh, good.
You said Governor Perry, you meant Governor Abbott? Is that right? His task force?
I was referring back to the...
Go back to
energy-
2004?
Yes, sir.
Okay. So in 2004, two things were happening. Governor Perry asked us to how do we maximize energy production in Texas. But what was also happening is a hydraulic fracturing revolution that you've heard about. And so I won't have to go into multi-stage and limited entry fracs to explain to you what all that meant. But what it meant was that we quit drilling dry holes and we left wildcatting and moved into manufacturing mode, which is what needs to happen in this industry, by the way. The marriage between the existential threats, the jugular vein of the state of Texas is the Permian Basin. If we lose Permian production, either because we are in violation of air emissions under the Clean Air Act, or we're having to deal with produced water under the Safe Drinking Water Act, that's going to be a tremendous blow, maybe unrecoverable in many ways, to the state of Texas, and even to the nation. So the oil and gas industry, and I've been a part of these projects over the years, and the oil and gas industry has always stepped forward and solved those problems, whether it's orphaned wells or site remediation or whatever the case may be. The Texas oil and gas industry has been incredibly responsible to the needs of our industry, and they're doing the same thing for produced water. We have to solve the produced water issue. When I operated, it was an expense. It has become a liability. We produce massive amounts of water from our fracking and our production. We can't put that on the surface. We have to dispose. That disposal has become overpressurized, and we're seeing seismic events and migration to the surface and so forth and so on. And the Railroad Commission has led on this issue, as has other state agencies. The ability, so Natura is partnered with the Texas Produced Water Consortium that was created by the legislature in 2023, I believe. $5 million, that's housed at Texas Tech University. Texas Tech is in the process of joining the Natura Research Alliance with the other 4 universities. So we're working with Texas Tech and the Texas Produced Water Consortium, working with Shepherd Power, NOV, the operators that generate the water, the gatherers that dispose of the water. We need to include the Texas Water Development Board. We heard Chairwoman Pop talk earlier about what that organization is doing, as well as the Railroad Commission. And how do we solve the produced water issue, the liability, turn it into an asset by generating more water for the state of Texas, at the same time, as Simon was just referring to, powering the Permian. The Permian gets 71% of our power from ERCOT. The other close to 30% is generated on site. That on-site generation is incredibly dirty generation that it adds to your air emissions problem. If we can provide clean, affordable, safe nuclear power to desalinate water and power the Permian at the same time, we solve a lot of problems simultaneously. So that's our partnership with the Produced Water Consortium is how do we do that? And how do we bring a new level of power, both in terms of electric power and thermal heat, into the Permian to help solve those problems. So that's it. And then on the downstream side, we don't talk about downstream much. So we have, Natura has completed feasibility studies for the Texas Produced Water Consortium. We're heavy on engineering and R&D. We've completed feasibility studies on marrying a molten salt reactor with a refinery downstream. And we've had some discussion of that with Dow and their work. But specifically on refining and what does that do to increase the fuel stock going into the refinery, as well as giving them the power and heat that they need for their operations. So the oil and gas industry and the emerging advanced nuclear industry in Texas is a partnership made in heaven. We need all the oil and gas, and I'll say again, coal, that we can possibly keep on production for as long as possible, decades to come, while we see the advanced nuclear industry kind of grow into maturity.
Brian, I want to talk about the specific power needs and the specific geography. We've touched on it a little bit already today, and how they're really cost drivers for electrifying the Permian, in the sense that very spread out area, very low density population-wise, and what role does nuclear specifically, small modular specifically, and Oklo's powerhouse, how can they help solve the cost issue of trying to provide 16 gigs of electricity to the Permian Basin?
I think we always have to go back to what is the problem we're trying to solve and who is the customer. I think oftentimes in these conversations, we're hearing what advocates want, what regulators want, what policymakers want, but the customer is left out of this. And I think this is a great example. I agree with the comment that gas and advanced nuclear are a match made in heaven, both on the customer side. So these oil and gas companies are our customers, as evidence that Diamondback Energy, for example, is a customer of Oklo. We're working on to deal with them in the Permian Basin. But we're also partners on providing bridge power, especially for these large gigawatt scale data center campuses in hundreds of megawatts, because the timeline they're looking at is 24 months. If you can't deliver power in 24 months, they're going to move on and deprioritize your project. So the oil and gas industry are customers and partners, and there's tremendous synergy. Now, I want to drill into this, really talk about that customer-centric approach. Well, we were talking with one of the largest operators in the Permian that operates in and around Midland. They sent me a list of 7 projects, 7 different locations to basically give them a cost estimate on. Those 7 locations were, some of them were 5 miles apart, 10 miles apart. They were all in and around Midland, though. They weren't that spread out. Well, and most of the power requirements were, some were 15 megawatts, some were 30, some were 70. I think the most was like 110, but they're all right in there. And my first inclination was, well, these are all clustered together. We'll just centralize our deployment and serve all of these areas. Absolutely wrong assumption. You can't, because the transmission capacity isn't there. And he said there is no way at all we will be able to build new transmission capacity. Absolute deal killer right there. And so this is a good example. You have to start with the customer. A 100 megawatt reactor is too big. It won't work, period. We can argue all day long about should we do large plants or small plants. Our arguments don't matter. It matters what does the customer need. And in this specific use case, in and around Midland, for this, one of the largest operators in the Permian, if you're not building 15 or 50 megawatt units, it's not going to work, period. It's completely uneconomical. It's not even, it's a showstopper. So I think we always have to go back. What does the customer want? And in this case, I think having a more distributed architecture that doesn't require massive investment in new transmission is a great solution. And it's really going to help them decrease their emissions profile, obviously, and also speed. You're not having to wait for that transmission infrastructure to be built, which can take a very long time.
Commissioner, wanted to circle back to you. Obviously, we talked about a minute ago, oil and gas industry is, sort of the bread and butter of the state of Texas. It's the, most important industry we have here. Railroad Commission does an incredible job of regulating both, ensuring safety and environmental safety, while also allowing the industry to operate and to produce. my question for you is, in the role of oversight of oil and gas, pulling from that experience, what potential obstacles do you see as we start to deploy nuclear, not only in the state, but specifically in the Permian Basin?
Yeah, one of the things that I often talk about when I go around and give speeches publicly is a lot of people don't realize the oil and gas industry is not a stationary warehouse. It has to continually move to increase its production or to maintain its production, drilling new wells. Something you kind of touched on just a little bit earlier is how do we keep up with that electrical demand as we move throughout those formations? And you're exactly right. I mean, that is where you've got to kind of start and be a partner with the industry on how do we continue that success and build upon those volumes to continue the things that we've seen. I think that when you look at the ability for nuclear to be mobile and to be designed and built for that transition and that path as we move forward in those formations is a great way of doing that. You know, infrastructure as far as delivering that electricity, it's always moving, it's always changing. So when you talk about hurdles, I agree that those hurdles could be, how do we get that infrastructure to make sure that we can stay up with the way that this industry moves? And I think that's going to be a real important thing to work out in the future. The other thing that I always say publicly is, as you talk about nuclear, if I went outside and I said, everybody leave, and I just brought in the same amount of people off the street, and I said, we're gonna power some of our power supply now utilizing nuclear, people don't like that word. And I see this a lot at the commission. When people come in and want to apply for permits, I always tell them, did you go out and did you tell people exactly what you were trying to do and why you needed to do it and how it would benefit the state of Texas and people that live within the state? I think it's important that we, as we develop nuclear, a needed source of electricity for us to continue our success, is that we need to develop good plans of how we're going to address those public concerns as we move forward in the future. And that needs to be in partnership with the oil and gas industry.
Simon, I want to zoom up a minute. I think one of the things that's so fascinating about the synergies between oil and gas and nuclear is the different levels at which you start to see these synergies. I mean, we're talking at a pretty granular level right now in terms of nuclear's ability to provide power or to desalinate produced water. It's all very specific, to Brian's point, very specific problems that the customer needs. If we look at this from a macro perspective and the electricity mix here in the state of Texas, how do you see natural gas and nuclear as sort of the perfect 1-2 punch for providing electricity throughout the state?
Right. Well, in terms of electricity provision, if you want to meet the customer where they are, you have to recognize the reliability for any power customer is top of the list. Cost, affordability, and reliability. If you have a distributed generation model, which a small modular reactor sits into a distributed generation model, you have to maintain affordability and reliability. The reliability piece, you require some type of system effect because there's no way that one nuclear reactor, even though it's operated with a utility factor of getting in excess of 90%, it's very well maintained, very well run. But if you can get past 95%, it's probably heroic. You still need to maintain the thing. Okay, you can't, if you take it down, you can't have your customers suffering lost production. That's a real economic cost to them. If it's an industrial, it could be a very severe cost. It's certainly an economic cost in terms of lost production. And the data centers are almost saying that's unacceptable. You need some type of system effect. If you're plugged into a massive grid, you just get the system effect from the grid. You produce 95% of the time. When it's not producing, you just get it from the grid. But when you're looking at a distributed generation model and you want to deliver reliability to your customer, your best possible partner is natural gas. Okay, it's well supplied itself, particularly in Texas. good pipeline network, and you can have a power plant at the local level get you that system effect where you both have natural gas and nuclear operating together. Some small modular reactors with some design features that are usually associated with the technology that they're using, you can, at the back of the power plant, where your steam systems are, where your switch yard is, you can start integrating natural gas into that. Either as a thermal source, or you actually have a combined cycle or natural gas thermal generation on the site. Those two things together give you the ability to, you're partnering with natural gas. They're both a customer of yours and they're a supplier to you. So I think there is a natural synergy between the nuclear industry and natural gas in the context of distributed generation to a lot of customers, including data centers. It's a bit of an epiphany for us. When we started 10 years ago, we took the view we have to compete with natural gas. But in terms of the way the energy market from a macro perspective has evolved, and I suppose if you took a long view of history, energy market is always additive. You're always trying to meet the next level of demand, and it's always increasing. So if you looked at how you meet the next level of demand, you meet the next level of demand by producing the highest quality product and the best proposal you can for your industrial customer group. And in our opinion, that's associated with a partnership at the plant level, basically with natural gas. And we can create that partnership because our system, our power plant design is capable of integrating natural gas early into its construction. So you can supply that magic ingredient, that important ingredient, which is power early. If I could just make one other point as well in terms of the SMR proposition to not just the data center guys, but also the oil and gas community. You're dealing with a business community that says, I have a plan, I want to execute my plan in 5 years. If you come to them and say, I'll tell you what, that's very good, but let me tell you my plan. My plan is you adopt my system in 10 years. They'll go, your plan is very interesting, but I need to tell you again what my plan is. So if you're listening to them, you'll recognize the most important thing is to go to them with a plan which allows them to be supplied with reliable, affordable power in 5 years. And if you are to do that, you have to have some type of both technology partnership and commercial partnership on the supply side with natural gas. And that's the opportunity for nuclear partnering with natural gas. It's not just at the grid level, the big grid level, where you have nuclear generation, you have natural gas generation, but it's also down at the much smaller local level, even the plant level, where you integrate the two together as well. That is the opportunity. It's the opportunity to deliver transformative new generation to the data center community and the oil and gas community. It's particularly relevant to the Permian, because I think this distributed generation model, together with the degree of electrification, is a very interesting and quite unique model in North America, and it's sort of quite unique to the Permian. So we see a lot of synergies now between ourselves and the natural gas community. It's good for us, it's good for them, and our experiences in the last 12 months have been super exciting.
Brian, I heard you talk recently about sort of same topic here, about the synergies between natural gas and nuclear when it comes to capturing AI data centers and making Texas sort of the leader in AI, or continue to be the leader in AI. Just want to give you a chance to comment on the importance of building natural gas as a bridge to nuclear.
So data centers right now, there's going to be likely in the next 12 to 24 months, somewhere in the ballpark of 20 gigawatts of nuclear power deals across the industry, based upon what I can tell from various conversations and what we're seeing. Texas has a massive opportunity right now to have a significant portion of that done here. And specifically, it's likely to happen in Dallas-Fort Worth. Most of these data centers are not interested in going to west, in terms of Midland area. They want, for a whole variety of reasons, which is beyond the scope of today in terms of network effect, in terms of infrastructure, workforce, et cetera, they're going to want a site in and around the Dallas metro area. But when they're evaluating different opportunities, it's even just last week, one of the largest co-location providers in the world told me, basically, just now they're considering new sites that have gas but don't have an electrical connection. That was unheard of. That would have not even happened. This is a massive company, right? So now they are considering, that's how desperate they are. They don't have power anywhere else. So Texas has this opportunity because they're going to go to Virginia, or they can go to Salt Lake, or they can go to Reno. They don't really, I mean, there's 3 regions in the U.S. They're going to have major campuses in the east, mostly in Virginia, in Columbus, Ohio. They're going to have a major campuses in the center of the country, hopefully in Texas and Dallas-Fort Worth. And then they're going to have another hub of campuses in the west, and that's going to be a combination likely of Salt Lake, Phoenix, Reno, maybe some in Oregon. That's it, right? That's where they're going. They're not going to go out in the middle of North Dakota or other places. So you guys are really, really well positioned and they're going to make these purchase decisions in the next 12 to 24 months. So there's this window. And everything is about speed. Emissions secondary, everything else secondary. The number one problem, again, back to the customer. What does the customer want? The customer wants speed to market. That's the problem you got to solve for them. And if you want to solve that, you need bridge power. You need to be able to say, I will get you power in 12 to 24 months at this site, and I'm going to give you a clear pathway to a 24/7 clean energy resource. So what we're basically selling is, hey, we'll build a gigawatt scale campus for you. We'll give you power in 24 months, and then we'll start phasing in additional 50 megawatt powerhouses as you build out that campus till you scale to a gigawatt, and we can do all that on 50 acres of land. So 50 acres of land, a gigawatt of power in 24 months with a clear path to clean energy. That's the kind of solution set that you need to present. Because if you're talking 5 years out, forget it. You're going to miss that boat because they're making purchase decisions now for that kind of time window. And the last thing I'll say on that, this is why business model, what Oklo is bringing to the market, I think is really the most important thing is the business model. The power as a service, not having a third party come in to operate for us, that we are basically the one throat to choke, right? We don't get paid until we sell kilowatt hours of energy to that customer. And that has not historically been the business model in the industry. And we're asking other people to share all this risk and adding a lot of complexity. That's what the customer wants. They do not want to own and operate a nuclear power plant. They don't want to maintain it. They don't want to license it. They don't want to finance it. They don't want any of that. All they want is they want power and they want a contract for it. And as we're seeing in the market, they're happy to pay 10 cents a kilowatt hour or whatever it is to have access to 24/7 baseload clean power. So that's, I think, the key unlock. And that's what, when you think about it, that's what Amazon did with cloud services. They didn't invent new servers. They just had a new business model. Business models transform industries. They offered compute as a service, and all of a sudden they started all of the cloud. And any Fortune 500 startup could plug in and buy compute as a service. Well, until now, utilities were their only game in town. Large energy customers like data centers or factories or these sites didn't have this option. So business models change industries, and that's what we're doing here.
Great. Doug, I want to talk about what I think is maybe a future synergy between oil and gas and nuclear. Just drawing on your background in the oil and gas industry, you know, obviously there's a lot of talk about potential hurdles down the road for the industry as it regrows itself in terms of, you know, workforce and how we can learn from the oil and gas industry in training a workforce, and also when we start to look at manufacturing these reactors, how we can look at, you know, how the oil and gas industry has really taken that assembly line mindset to create efficiencies that we see in the Permian. So just curious your perspective of how we may as an industry learn from oil and gas in that respect as well.
So I spoke at the American Petroleum Institute up in D.C. earlier this year. The subject they gave me was how is nuclear different than oil and gas? And what I actually spoke on is how we need to emulate what the oil and gas industry did 20 years ago. And so this is what happened 20 years ago, and you know, my company was a part of it. In the Barnett Shale, which is natural gas, and in the Permian, which is crude oil, we went from wildcatting to manufacturing. I don't know if you're familiar with the term wildcatting. Wildcatting is, you know, mostly failure, destroyer of capital. And really what got me thinking about this was Governor Perry called me the pioneer of the future of energy in Texas, which I don't know if I accept that title, but someone picked up on that and said this oil man is wildcatting and nuclear. And when I read that, I thought, you know, I think he's right. Right now, there's dozens and dozens of projects out there. Most are going to fail. Some are going to succeed, maybe the 3 on this stage, others hopefully. And that's wildcatting. What we did in the oil and gas industry 20 years ago is we quit wildcatting because of the change in technology. We were able to source the mother rock, source rock, which is why we no longer drill dry holes. So every well we drilled was productive and was economic. So think of a rigged roulette wheel. If you're going to win on every square, every spin, how much money do you put on that table? All of it, right? So when we started developing this technology, 2003, 2004, 2005 is when it all started happening. It took the financial industry, who are usually the smartest guys around, they figured out, wait a second, you guys aren't drilling dry holes anymore. And then we saw $80 billion of private equity trying to place in the Permian to get in the game at that point. Well, when that kind of money hits the table, then things start to happen. Not only were we drilling at a pace that we had never drilled before, then you saw industries being stood up, and this is what's going to happen. This is what the power of capital. I don't think a lot of this requires regulation. I think you let the marketplace work its way out. We saw steel mills reopening on the East Coast to provide drill pipe and drilling rigs to the Permian Basin. We saw sand mines opening up in Wisconsin to provide frac sand for the Permian Basin. The only new rail being laid in the country was being laid in the Permian Basin to handle the commercial traffic. I would take commissioners, Commissioner Wright, I don't think you ever made one of these trips, but out to the Warfield truck stop at 6 o'clock in the morning in Odessa, Texas, to watch the oil field come to life. It looked like Patton's Third Army. It was just amazing. When that happened, then you saw regulatory reform. The Railroad Commission, think of them as the NRC for Texas. You will not drill a well in Texas until Commissioner Wright gives you a drilling permit. It took the Railroad Commission 8 weeks to issue drilling permits, which was plenty because we would drill and watch, drill and watch, drill and watch. Well, once you quit wildcatting, you don't watch, you just drill, 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 drill. We call it carpet bombing. So you're moving at a pace. So I got a call from the chairman, Jim Keffer of House Energy, saying, Doug, you need to come down and help us solve the permitting problem. Met with the Railroad Commission. John Tintera was chief of staff at that time. John, what do you need? This is what we need. What do you need, Doug? This is what we need. Credit to the Railroad Commission, they went from 8 weeks to issue a drilling permit to 3 days because we gave them the opportunity to do that. That's what I think the NRC is going to be given, that opportunity. When we go to them for a permit, and the permit for this reactor is exactly like the one you approved yesterday. Well, what's the next one? It's going to be the same thing, and the same thing, and the same thing. And so then what you're doing is site permitting, and Shepherd NOV has done tremendous work with the NRC on getting the site permitting, because where you're going to put the reactor matters. That could be down to 180 days. And so now we're looking at a 6-month permitting process. And then we talked about limited delegated authority. The state of Texas would have the authority. I don't know that I'm ready for the states to license reactors, reactor designs. I think the NRC is the world's gold standard on that. And we have our permits, so we're happy with how they do their work, obviously. But if the NRC approves a design of an advanced reactor, and now it's a matter of where you're going to locate it, and are you building according to an NRC-approved design, perhaps that could be delegated to the states. And now you have competition among the states, just as we do in the oil and gas industry. 1/5 of the Permian Basin lies in New Mexico. Now, if you look at the drilling pace in Texas versus the drilling pace in New Mexico, there's a difference because there's competition between the states. And so if we get that level of competition between Texas and the other 20 states that are saying, we want to be advanced nuclear, how are you on site permitting? How are you on placing reactors? That's when you get the efficiency of competition. So we did this 20 years ago, and we made the country energy independent when we did it. I spoke to Oak Ridge. I was there last couple of weeks ago, but a year ago I spoke to Oak Ridge at the Molten Salt Symposium, and I told the room, and probably maybe more than in here, and I said, if you can put as much power on the grid with advanced nuclear that we did in the Permian 20 years ago, good job. And so we've done it in Texas. We can do it again. I think we saw what the pathway looked like. It's new technology, proven, the ability to get permits, the ability to manufacture. Our partnership with Zachary Nuclear, Zachary Engineering, Teledyne Brown, all part of that supply chain to develop. Then you see the money hit the table. When the money hits the table, everything changes.
Commissioner, I want to talk about water real quick. It's obviously a big issue in the Permian. Is there enough water to go around for oil production and nuclear in the Permian?
As far as fresh water is concerned, no. I mean, I don't think it's a mystery now that Texas is in some pretty severe drought conditions, pretty much everywhere west of the 98th meridian. But I will say this, and I think it's important for people to understand, when I said that figure earlier of 6 million barrels a day of crude oil that we're producing, with crude oil and natural gas, we also have water that comes up alongside that, and we call that a water cut, or we also refer to it as produced water. That water is about 4 times in the water cut. So if you do the math, it's easy to see that we're roughly 25 million barrels a day along with that generation. That's a lot of water. And then I think Doug touched on it earlier that part of that play extends into New Mexico. Some of that water issue has caused seismicity and some overpressurization problems, and New Mexico's already put in some rules and regulations which has pretty much forced a lot of that volume of water back into Texas for economic reasons. And so today when we talk about, where is this water going to come from and what are we going to do with it, I think water today and the challenges that we're seeing with seismicity and overpressurization, and I'm proud to say that we've started a couple of years ago addressing this at the commission, that we have 3 pilot programs that are working today in really treating this water and treating it in a safe, economic way for beneficial reuse. Today we're using a lot of that water in irrigation. But when you look at what New Mexico and Texas has, that's about 30 million barrels a day. So when you see the drought conditions that we have, the water needs for industries like nuclear that's going to be coming forth, I think we have plenty of water. I think that's going to be part of the transition. To clean that water appropriately, we're going to need power. So, all sources of power, not just nuclear. But nuclear would go a long way in helping us achieve that we could utilize that volume of water, not just for the industrial needs that we have today, but for drought conditions that we're experiencing here in Texas. So I don't think water is the big issue. I think we've got to get to where we can get it treated, do it environmentally safe, and do it at an economic level that it makes sense.
I've been told we only have a couple minutes left, so we're going to do a lightning round here. One of the public perception concerns, and I'm not legitimizing it, but one of the things I think that we'll run into as an industry when we start to look at deploying nuclear in the Permian is the safety issue. So lightning round for the developers up here. I'm just going to go down the line if that's all right. Talk about how we're going to maintain safety in the Permian even though we're going to deploy nuclear.
We have to educate. We got to really reach out to these communities and educate them because there's a tremendous amount of ignorance out there. These reactors, for practical purposes, are meltdown proof. You can't melt them down. Our emergency planning zone is the 2-acre site footprint. There's no land buffer zones or setbacks whatsoever. That means in the worst case, catastrophic event, some terrible natural disaster comes and knocks the plant out, all the operators are incapacitated, there's no backup power, all the pumps and motors are not working. There is no radiological release beyond the site footprint. 2 acres for each 50 megawatt powerhouse, that's the emergency planning zone. Large light water reactors require 10-mile emergency planning zones. So we have to educate people. All the public cares about are 2 things. Is it safe, and what about the waste? And these are meltdown proof. They're completely safe. You got to be thoughtful, you got to engage, you got to educate, but there's no reason why this is just not a massive economic development story that will bring tremendous jobs, tremendous energy resilience, large energy customers that aren't going to compete for power. It's a tremendous value to the community. And the last thing is the waste. We recycle the waste. We're solving an existing problem. So not only are we taking all of that spent fuel and turning it into 24/7 clean power, we're recycling the waste coming out of our powerhouses. And we can do that over and over and over again. So we have a great story on both those concerns that will neutralize both of those arguments.
Simon, lightning round.
Yes, I think if the industry, the nuclear industry, speaks its truth clearly, we will win over the public. I think we've seen that process in play for the last 10 years. It's the right trend line. In terms of safety in the Permian, I think we have to also remember that nuclear, to be safe and to comply with existing NLC regs on a nuclear plant safety and security, it's about guns and guards. Nuclear doesn't do small very well because you need guns and guards. And with a small modular reactor, you are likely to be able to avoid emergency planning zones 10, 50 miles. It doesn't have a good ring to it when you tell the local community they are sitting in what's called an emergency planning zone. Just psychologically, I don't think it has a good resonance to it. So with small modular reactors, you could have the emergency planning zone, potentially at the security fence where you have your guns and guards. But I think if we speak clearly, the value of nuclear, do it consistently, we will get the necessary social license.
Doug, final word.
So our experience in Abilene is not that. This project has been public in Abilene for 4 years. Our demonstration reactor is going to be located on the Abilene campus right across from a brand new boys and girls dormitory. I'm on the ACU Board of Trustees. I think there's more concern about what's going to happen in the dormitory versus what's going to happen in the reactor building. We have had more tours with every aspect of Abilene we can envision, whether it's elementary schools, art centers, the chamber. We've had town halls. We have not had a single voice of dissent or concern. Nothing but overwhelming support and excitement about the project. A lot of curiosity, a lot of desire to come and see and watch as we move forward. I think I heard Chancellor Sharp say the same thing. I think he said he had one email, perhaps. So our experience has been that is not the concern. In the Permian Basin, that's an energy production universe. I mean, the floor of a drilling rig is much more dangerous than a nuclear reactor. I can promise you that. And we don't. And I'm putting my oil and gas hat back on for a second. We understand. I've had rigs burned down. Thankfully, no one was on when it happened. Injury is not uncommon. Death is not uncommon. Unfortunately, it's a hazardous industry, yet we keep drilling, we keep producing because we have to. We don't have a choice. We don't have the luxury of not doing that. Nuclear is safe. It's the safest form of energy we have. I think particularly for the younger generation, they get that. And there's survey after survey after survey showing that. So that's not the battle we're focused on. We've done a great job. Abilene Christian has done a great job in educating the public. And as I said, in over 4 years now of a highly public, highly accessible project to the city of Abilene, we have not encountered any of that dissent.
Commissioner, gentlemen, thank you all very much. Appreciate it.